In this video, we are going to determine laws of logarithms, and we're going to show how to use those laws of logarithms. But before we begin, it's important just to define one thing for you. We're going to define what's called the natural logarithm. Now, the French call natural logarithm logarithme naturel. And rather than write that out, they say that that's ln. Now, you'll notice your calculator has an ln button. What ln means is log base e, and e is specifically an irrational number that's approximately equal to 2.718. So when you see in your calculator the log button, the ln button, what we call ln, that means log base e, where e is roughly 2.718. Now, one other thing to keep in mind while we're going through this is just remember that the log base a of a to the b is equal to b. So just think about this for a second, and then it'll be something that we'll remember very well. Suppose I told you that I wanted you to evaluate the log base a of a to the b. Well, one way you might do that is to say, okay, I'm going to let it equal x. Now, when you have an equation like this, you say that the base of the logarithm raised to this exponent is equal to this entire quantity here. Well, just from observation of this equation, very simply, we can say obviously x is equal to b. But x is equal to this right here, so we can put a b there. And we can say the log base a of a to the b is equal to b. Okay, so just keep that in mind. It's something that I'll come back to numerous times during this lesson. The log base a of a to the b is equal to b, and something else that we'll come back to is something called the logarithme naturel, which is log base e. Okay, let's get into this discussion. We're going to develop three very useful laws of logarithms here. We're going to develop what's called the product law of logarithms, which says that the log base a of the product mn is equal to the log base a of m plus the log base a of n. This rule of logarithms is kind of a cousin to the law of exponents that says that a to the m times a to the n is equal to a to the m plus n. Logarithm rule number one and this rule of exponents are related to each other. Then similarly, we have another law of exponents, which is log base a of m over n is log base a of m minus log base a of n. Well, this is very much related to the law of exponents, which says a to the m over a to the n is equal to a to the m minus n. These two laws are related to each other. And finally, logarithm rule 3 says log base a of m to the n is n log base a of m. Okay, and this is related to the power law of exponents. And one thing to notice, just like laws of exponents require the same base in different powers, laws of logarithms require the same base in different logarithms. So we have log base a, and then we have log base a. So we need to have the same bases here in order for these laws of logarithms that you're about to see to work. Okay, so let's develop them one at a time. Let's start with the product law of logarithms. Suppose a and m and n are all positive numbers and that a does not equal 1. Okay, so just to keep it simple, suppose for a moment that a was equal to 3, m was equal to 12, and n was equal to 15. Just guessing at random numbers here. Well, there will be some value of x such that m is equal to a to the x. So using our random examples above, 12 will equal 3 to the exponent x for some number x. We don't know what it is, but there is a number x that completes that. And similarly, n is equal to a to the y would be like saying 15 is equal to 3 to the y for some value y. We don't know what the value of x and the value of y are, but we don't have to right now. We just know that if we let a, m, and n all be positive numbers, that there will be these values of x and y that make these two comments true. So if we can live with that, then we can move to the next step. Now, in the next step, we are saying the log base a of m is equal to the log base a of a to the x, because a to the x is m. And then, as was said on the first slide, when we see log base a of a to the x, we know that that's x. So what we're going to put as equation 1 is log base a of m is equal to x. And this is going to be our equation 1. We're going to come back to it later. And similarly, when we say log base a of n, well, we know n is equal to a to the y. It says it right here. And based on the discussion we had on our first slide, the log base a of a to the y will equal y. Okay? So in other words, our second equation will say that the log base a of n is equal to y. We're going to call that equation 2, and we're going to come back to it later. Okay? Now, moving forward, we could say the log base a of m times n is equal to the log base a of a to the x times a to the y, because m's a to the x, n's a to the y. And we know that this expression from our laws of exponents is the same as a to the x plus y. So we have log base a of a to the x plus y. But the whole discussion on that first slide before we started was that this log base a of a to the exponent would just equal the exponent. So it just equals x plus y. Okay? But now go back to equation 1 and 2. X is the same as log base a of m. And y is the same as log base a of n. So instead of saying equals x plus y, we can say it equals log base a of m plus log base a of n. And so we've actually got the rule. The log base a of mn is equal to the log base a of m plus the log base a of n. Okay? And so it's a little bit of fancy footwork going on there, but what we've created is a very valid rule that we're going to use a lot. The log base a of a product is equal to the sum of the individual logarithms. And as with all logarithms, the base of the logarithm must be positive, and and cannot equal 1, and the arguments of the logarithm, i.e. the thing that we're taking the log of, they have to be greater than 0. Okay, that's the product rule of logarithms. Well, what's the quotient law of logarithms? Well, let's look. Again, suppose a, m, and n are positive numbers. For the same reasons we said earlier, there will be numbers x and y such that m is a to the x and n is a to the y. Okay? And so we're going to keep in mind for later that, therefore, the log base a of m is x and the log base a of n is y. And keeping that in mind, we can then develop our formula. The log base a of m over n will be, since m is a to the x and n is a to the y, this will equal the log base a of a to the x over a to the y. But we know what a to the x over a to the y is. It equals a to the x minus y. And for the reasons stated in the first slide before getting into this slideshow, the log base a of a to the exponent x minus y is simply x minus y. But of course, x is log base a of m, and y is log base a of n. And so we can rewrite x minus y as log base a of m minus log base a of n. And we now have the formula that we were trying to establish, that the log base a of m over n equals the log base a of m minus the log base a of n. Okay, and we can formally state it, and we can say that a has to be greater than 0 and not equal 1, because we said that in a previous video. That'll always be true of our bases of our exponents, and we know that the bases of our logarithms, and we know that the arguments of our logarithms have to be positive, again, for reasons we said earlier. And finally, let's talk about the power law of logarithms. Well, suppose, same setup as the other two, suppose a, m, and n are positive numbers and a does not equal 1. Well, just as stated earlier, there will be a real number x such that m is equal to a to the exponent x. Well, again, for the same reasons that we've said earlier, it'll be true that log base a of m is equal to x. And so now, when we state our the thing that we're trying to establish, the log base a of m to the n, we can replace this m with a to the x. But we know a to the x to the exponent n. We can multiply these two exponents and just have a to the nx. And as stated on the first slide, log base a of a to the exponent is just equal to the exponent. So log base a of a to the nx is just equal to nx. But recall what x equals. X is equal to log base a of m. And so putting all of that together, we can say that the log base a of m to the exponent n is n log base a of m. In other words, we can take this exponent in front and just move it. We can take that exponent and just move it in front. And so we get our final law of logarithms for the purposes of this slideshow, which is the one shown there. And so there's some examples here, and we're going to go through those in a later presentation, in a later video.